there. All right, so what do you want to start with? There's 10 possible questions you could be asked, right? And those are all in the ADN study guide, and those are all the categories. So which category are you itching for? Percentage ratio, okay. So percent stuff, all right? What is percent stuff? So that means you have something, right? You have a box of something, you have, oh, auto-corrected, all right? Or you have a vial of something that has a percent in it, right? And it has, that's a certain percent concentration. Percent concentration is always the same it's always of 100 mLs, no matter what, right? So whatever it is, right? Whether it be MEQs, whether it be milligrams, whether it be units, whether it be micrograms, whatever it is, it's per 100 mLs, right? So that's kind of where you start. You have to bring that into the test, right? So it's X. So X could be anything, right? It could be units, it could be MEQs, like bicarbonate is 8.4% per. It says 8.4% bicarb. How much do you want to give? I want to give 25 cc's. Well, how much bicarb is that, right? So let's do that, right? So say X equals 8.4%, right? This is like bicarb. Bicarb says this, okay? So what is 8.4% bicarb? It says MEQs. I mean, really, units at this point, we're not really, I guess it does matter because the question is going to ask you how many MEQs are you going to give, right? So that's what the question says. How many MEQs will I give if I'm giving, let's say, how many mLs do you want to give? You want to give 10 cc's? You want to give 25 cc's? Usually in real life, it's a 50 cc vial, right? They call it an amp of bicarb. So how much of that 50 cc's do you want to give? 22.5 is what I heard? 22.5 mLs, right? So how much is that? So the question is, how many MEQs are you giving? Where do I even start? I want to know, do I know how many mLs? No, it tells me how many mLs. I want to know how many MEQs. But it could ask, you're giving 10 MEQs, how many mLs is that, right? The question could ask either way. It's still assessing your knowledge of, do you know what percent concentration is, right? So that means you have to bring in what is, how many, you have to know that it's X amount per 100 mLs, right? So this is 8.4 MEQs per 100 mLs, right? So we're solving for MEQs. Let's do a different color, okay? So we're doing MEQs here, so let's do MEQs on top, right? So 8.4 MEQs. That really coming up, not great, but 8.4 MEQs. Let me see if I can darken this. Here we go. All right, 8.4 MEQs per what? 100 mLs, right? So 100 mLs times what? We're solving for MEQs, right? That's our goal here. So what are we missing? We got to cancel out what? mLs. Do we have any mLs in our problem? Yes. If there were other distractors like your pH is 7.39, your PCO2 is this, your bicarb is 21, and your patient is on the ventilator at the tidal volume of this, and those are all distractors. You have to be, as the RN, you have to be able to pick out what is necessary, right? You have to be able to filter through all that BS, right? Like one of our jobs as RN is being a BS artist and be able to figure out what is important, right? What is the priority? What are the things I need to know, okay? So 22.5 mLs is the dose. Equals the dose, right? So what does that mean? So mLs cancel, so I get 8.4 times 22.5 divided by 100. What is that? 9.89? 1.89. Is that true? Everybody get 1.89? 1.89 MEQs. How the heck do you round MEQs? So if it's not in your rounded rules, I would have to give you what I want you to round it to, right? So we'll just say tenths, okay? Because in that first number one of the rounded rules, can you visualize in your head, right? Where it says A, B, C, D, and E, these are the ones you round to tenths. But if it's mLs, that's the exception, right? If it's mLs per hour, that's another exception, right? But mLs per hour, those ones you got to pump the brakes and say, wait, am I less than 1 or greater than 1? Or if it's mLs per hour, am I greater than 100 or less than 100, right? So the problem would have to, if I was making this as a quiz, I would make sure that your rounding rules had MEQs on it, right? Either way, let's say it's rounded tenths. So what is it? 1.9. So if we round it, that equals 1.9 what? MEQs? So that's how many MEQs we're giving. All right, so what's another percent? What's another those of you that have seen in the hospital setting, what are some other things you give as percentage or seen as practice problems? How about dextrose or lidocaine or albumin or, yeah. All right, so what about albumin? All right, so we're giving, say, go and give the patient 5%, let's do 25% albumin, right? It auto-corrected my A to a triangle. All right, so we're giving 25% albumin to somebody, right? So you have a bottle of albumin here. Oh, okay. All right. That you need to spike, right? So you spike your albumin right there, and you're going to give it to your patient. Okay. So that's going to go via the IV into the patient's arm. And it says, well, how many, let's say, grams of albumin are you giving the patient, or milligrams? What do you want to do? Grams. So we're going to solve for grams, right? So we're giving 25% albumin, right? So how many grams are we giving? Well, we don't know what the bottle has in it. How much is in the bottle? How much do you want to be in the bottle? 50, 75, 250, 500? 500 I heard, okay. All right, we're giving 500 mLs to the patient, and it's 25% albumin. How many grams of albumin did the patient get? Because, for instance, when you do paracenteses on patients, they have to give like 6 to 8 grams per liter, per liter you took off. So people with liver disease, they develop all this fluid in their belly, and we have to pull off that fluid because it's going to compress their lungs and they can't breathe. So you have to, let's say we pulled out, 5.6 liters via the paracentesis. We have to give 6 to 8 grams per liter to replace that volume we lost, so they don't get hypotensive because we pulled off 8 liters off their body, right? Right? They now weigh 56 kilograms, and they have a daughter who is 14 years old, and so these are all distractors, right? So which one of these red numbers do we need to use for our math? 500 mLs, that's all I need, right? I want to know how many grams I'm giving them. Well, I need to figure out how much is in the bottle, right? I know the bottle is X concentration, right? It's 25%, right, concentration. It's 500 cc's of that 25%, right? When I drink soda, I can drink a cup, or I can drink a big gulp, right? It's still, the concentration is the same, right? How much caffeine did I intake? How much sugar did I intake, right? How many grams of sugar of Coke did I take? Not like cocaine, but Coca-Cola. All right, so where do we start? So we're solving for what? Grams, right? So I need to put grams on top somewhere, right? So what is that? How is that?
25 grams
Per 100 mLs. Why not 1,000? Why not 500? Yeah, you have to bring this with you, right? You have to know if it's percent concentration, it's per 100 cc's, right? Per 100 mLs. Okay, so 25 grams per 100 mLs, and then what's next? Times 500 mLs. Okay, so that cancels out. 25 times 5 is what? 125 grams to the patient, right? So if that looks about right. If I put 6 times 5, sort of, maybe. All right, so it's 125 grams of albumin I'm giving the patient. So time. So in the Google chat, I gave you some tips on time. So for time, you have to know how many mLs are remaining. How many mLs remain, right? And you have to know the rate. How are rates? What are the units for rates? mLs per hour, right? And I have to know the current time. If the question is asking me what time is going to end, I have to know what the current time is, right? So what is current time? Correct? So these can be asked several different ways. So we can say mLs remain. We could say I have a bag right here. Look at the bag, and you have to measure there's 50 mLs remaining, right? Or it could be let's say it's 5 o'clock in the evening, and the bag's been going for an hour, right? Or let's say the bag is going at, it's good way to say that. I don't know, but they have, how many mLs are left in the bag, okay? And then rate. How do you get rate? Either just tells you it's going at 20 mLs an hour, or it's going at 150 mLs an hour, right? Or it's going at 1 gram per hour, and the bag the bag is here. And look at the bag. The bag shows 2 grams per 50 mLs, right? So it's 2 grams per 50 mLs, and it's going over, what did I say? I forgot my train of thought. Either way, you might have to figure this out. And this is using all your other skills for mics per kilo per hour, mics per kilo per minute, units per hour, whatever it is, right? So and then of course you have to know the current time, right? You have to know, is it 3:03? Is it close to midnight? When it's close to midnight, you have to do some mental math to make sure we are doing it correctly. So we know is it 3 a.m. or 2 a.m.? Did I remember to add the hour, subtract the hour when I went over the hour, right? So yeah, so rate, this could be any kind of math problem. Okay, so let's do one, let's just do heparin, for instance. Okay, so we have a bag of heparin, and the heparin is a concentration of 25,000 units, and it's not 25,000, hold on, 25,000 units per 250 mLs, right? That's what we're hanging, this is hanging on your patient with AFib. They're in the hospital setting, and we don't want to start a medication that costs $48,000 to reverse. So we're going to give them heparin drip while they're in the hospital, right? They were on apixaban at home for their AFib, but now we want to do heparin while they're in the hospital in case they get super sick and they have to go to surgery or something, right? So we give it heparin to the patient, and in the heparin bag there is how many cc's left? You guys need to go to an improv show where you have to shout out answers. 900? It's a 250 ml bag. So a little bit less. 75. All right, we got 75 mLs left in our bag, right? And then what's the current time? 7:30 a.m. 7:50 a.m. I guess is what my brain subconsciously wrote. All right, so it's 7:50 a.m. All right, and let's say pharmacy gives you a call and they say, hey, do you need another bag of heparin? And you say, yes, I need it at. So what time do you tell pharmacy? All right, RX time. What time are you going to tell pharmacy to make sure the bag is in your hands? Are we missing some information? The rate, right? So the rate is going at 10 units per kilo. Okay, per hour. How much does the patient weigh? 136 pounds. Somebody wants to use a conversion factor. Okay, so we're 136 pounds, we got 10 units per kilo per hour, we got the units there, we got the current time, that's going to get us a rate. I think we're in business, right? And we can add some other distractors, add another distractor. The patient on heparin drip, the PTT is 32.6. The patient has AFib at a rate of 126. The patient is 76 years old, right? The patient has a 10-year-old daughter, right? And a 35-year-old wife. The patient is 36. We're not going to make it weird. Okay? So what else? Where do we start? Which one is, we need to figure out the mLs per hour, right? If we have to, we know, we need to figure out like when's that's going to end. Let's say there's 75 mLs there, and it's going at this rate, right? If grandma lives 75 miles away and you're going 60 miles per hour, how long will it take to get to grandma? At what time? Well, I have Google Maps for that. So no, you're not going to be quizzed on Google Maps, right? On utilization of Google Maps. So that means we have to figure out mLs per hour, all right? That's our goal here. All right, so mLs per hour. So where do I start? So I need something that has mLs. There's what one here has mLs? 250. Let's put the 250 mLs per what? 25,000 units. All right. Now I think I see units somewhere else, right? Where's that at? What's next?
10 units.
So it's 10 units per kilo per hour. Okay. So 10 units per kilogram per hour, right? And then what else we need? We need to get rid of kilograms. So 1 kilogram or 2.2 kilograms, what is it? What's heavier, a pound or a kilo? 1 kilo is heavier, right? So 1 kilogram per 2.2 pounds times how much does the patient weigh again? 136 pounds, all right, per patient. Anything else we're missing? This will get us mLs per hour, I believe, right? So we got units, units, kilos, kilos, pounds, pounds. We're left with mLs per hour, right? Yeah, this is a multi-step problem. You need to know, you need to find the things. Sometimes the problem will give you everything. It says the patient's getting 25 cc's an hour, the time is 10 o'clock, and there's 50 mLs remaining. So it's going to finish in 2 hours, right? 61.8. Everybody else get 61.8? 61.8 what? mLs per hour, right? So what's next? What are we solving for? We're solving for what time did it finish, right? So where do we go next? Because we're solving for what? We're solving for hours, right? So 61.8, sorry, 1 hour is 61.8. So 61.8 mLs infuses every hour. That is 61.8 mLs per hour, right? Times what? How much is remaining? 75 mLs, I think, right?
Yeah. Sorry, Professor, I actually missed a zero, so it should be 6.16.
6.18. All right, that's good. As an RN, you need to be able to speak up, right? You need to say, well, something's not right, right? I'm saying, well, shoot, that's, you know, if the doctor says, or the pharmacy says, you're going to give the heparin at 61.8, you're like, well, this doesn't add up. My patient doesn't weigh this much, right? So that's good that we caught that. All right, I don't have a calculator on hand, so that's my excuse. So we got what?
So it should be 6.2 rounded.
So it's 6.18, right? So 6.18 equals how many mLs per hour? So if it's, what's the rounding rules for mLs per hour?
Below 100 to the tenths.
Yeah, below the 100 to the tenths. What if it's 100?
Then
Whole number, right? So yeah, so 6.2 mLs an hour, right? So let's adjust our next step right here. It's good because I messed up anyways. All right, so 6.2 mLs in 1 hour is how much infuses. How much was left in the bag? 75 mLs, right? So it's like your grandma lives 75 miles away and you're going at 6.2 mLs per hour you're going at 6.2 miles per hour on the freeway. When will you reach grandma? All right, how many hours will it take? Grandma, I'll be there in hour 21. You're going more than 6.2 miles per hour. So good point. So rounding and when to round. Do I round now or not? Well, on that pump right there, that physical pump that we can see with our eyes, can you program 6.18 into it? No. So we have to think of real life also. So what is my rate? I have to establish a rate first. I have to solve for rate. And that rate is going to be the rate I'm going to put in the pump, right? Like if I solve for, I don't know, like we're giving mLs to a patient, I'm giving 22.36782433 mLs, right? And that's how much, I can't get that much, right? That's not going to be possible. So this rate is what we can give put in the Alaris pump, right? So if we have a little pump right here, all right, nice, thanks for the autocorrect. So what I can punch in the screen right there is 6.2 mLs per hour, right? All right, so what do we get if we solve 75 divided by 6.2? 12.0967. What is that? Is that hours, minutes? That's hours, right? Yeah. So so the problem would have to tell you, because again, there's a gap here. There's a gap analysis for our rounding rules. It doesn't tell you, do you round hours now or do you round it at the end, right? So usually on the quiz, I give you if you round it or not, right? You'll get the right answer, right? I give you credit for both answers. If you rounded here, or if you rounded, or if you didn't, if you rounded to hundredths, right? So we'll round this to hundredths. Okay. So what is that rounded to hundredths? 12.1. Good job. So it gets tricky when you have a 9. Like, well, which one moves up, right? So the 9 moves up to 10, so that's 12.10 now. And we don't have trailing zeros, right, in nursing math? 12.1 mLs an hour, all right? Sorry, that's 12.1 hours. 12.1 hours, all right? So does that tell us information? Is that going to be able to give us the exact time? No, because you know 12 hours and how many minutes? Well, it's 0.1 minutes. Well, no, it's not, right? So So it's 0.1 or 10%, right? 0.1 is 10%, right? 0.10 is 10%. So it's 10% of an hour. What's 10% of an hour? 6 minutes. You could think of it that way. I mean, when you're doing a quiz, that you don't always have mental math handy, right? So we'll write it out, right? So how do I figure out how many minutes? Because what I'm doing here is, what was the current time? It was 7:50, right? Plus 12 hours plus how many minutes? Well, instead of doing mental math, let's just do it, because that's going to tell us our time, right? So how do I figure out how many minutes? What if it was like 0.13 minutes? That's a little more difficult, right? What if it was 0.236, or we'd round that, 0.24 minutes? So how do I figure out 0.1? Yeah, so I want to solve for minutes, right? So how many minutes is it? It's going to be, well, yes, it's going to be 6 minutes, but how do I set it up? So 0.1 hours over, really I want to solve for minutes. So if I'm going to do this methodically, I would just be solving for minutes. There's 60 minutes in 1 hour, and I have 0.1 hours, right? So 0.1 times 60 is 6 minutes, right? So I'm adding 12 hours and 6 minutes to my problem. I mean, if I was going to probably give you this quiz, I'd probably make it so that your minutes go over past the hour, right? By the way, what's 12 hours from 7:50? 1950, and then plus 6 minutes is 1956. Okay, did that make sense? Do you want to do another one? Yes.
Just a quick question though, so just on an example going off from here. So when we got the 12.0967, you want us to round to the hundreds, or does it matter if we do 10?
I would tell you in the problem. So what if you did 0.0967? What is 0.0967 times 60? It was still 6, right? So this one evened out, which is nice, right? So that way I didn't have to give you two options of correctness on the quiz. You would have got to the same answer every time. This is what I do when I make the math homework. I try to make it so it lines up. 5.8, yeah, we're not getting down to the second. It's like pharmacy is okay, 22 seconds, let's go. Yeah, so that one we just don't want minutes. We're not going to get crazy in seconds and milliseconds, right? Because that's what you do if you each one of those other things, right? All right, so insulin. Okay, so when you do insulin, what we can ask you is just how many units you're giving, right? So you can't be too creative with this. This might have a table on it, right? So it says you have sliding scale insulin, right? So we're trying to figure out how to ask you a question. You have sliding scale insulin, you have high, medium, and low, and you have different glucose results over here, right? So it has to be, can you read a table, right? Can you make sure you don't go down a row and capture the wrong insulin, right? So sliding scale insulin is, as we'll learn, next week? Or week after, we're learning about the different types of sliding scale insulins, which are going to be the quick-acting, immediate, or fast-acting insulins. And then you have insulins that you give that are given daily or given maybe twice a day. Okay, so you have to be able to read the problem and understand what am I giving now at 8 o'clock? What am I giving now at noon or at 4 o'clock? Right? So there could be distractors in this kind of problem what am I giving now, right? If Lantus is given or Detamir is given at 8 a.m. every day and it's 10 p.m., I'm not giving Detamir, right? I'm not giving that type of insulin right now, right? But the question can ask you, how much of that long-acting Detamir are you giving? Okay. What else can you ask with this? You can maybe ask someone how many units are in the syringe. Like, look at this, but that's a little bit too easy. That's not math. That's just eyes. Okay, so math would be interpreting tables, interpreting data, right? All right. Do you want to do a sample? I mean, you just have to just make up numbers. We can try to get crazy and try to figure out have a really sick diabetic patient, right? So the diabetic patient is on 22 of Detamir. They get 30 of 70/30 insulin at 1600, let's say at 10 and 1800. They get 22 Detamir at 0800. Right? They're on sliding scale insulin, and they're on preprandial insulin of 12 units of regular preprandial. and they get sliding scale insulin of, let's say, high dose, because this looks like a high dose kind of patient. They're taking a lot of insulin, got really bad diabetes, right? They're getting sliding scale insulin high dose, and so let's make a high dose scale right here. Give me some numbers. And they're small numbers. They're like 0 to 12, or 2, 4, 6, 8, 10, 12, or 3, 6, 9, 12, 15. What do you want? 2, 4, 6, 8 is medium. That's lowballing, right? You pump those numbers up. All right, and we got 3, 6, 9, 12, and we got, let's do 1, 2, 3, 4. All right, this is our sliding scale insulin table right here. But now we need some sugars. Like, what if my sugar is 150 plus? I'm doing this row right here. If my sugar is 200 plus, I'm doing this row right here, right? If my sugar is 250 plus, I'm doing this row. Sorry, it should be 200, 250, right? 249. I'm not going to waste the time. But if I'm 300 plus, I'm right here. Okay? Does that make sense? So 150 to 199 is 1, 2, or 3 units, right? And then what else can we do to make this complicated? We can ask a few things. We can say, how much total insulin are they getting over the last 24 hours? Or how much insulin do they get since admission? We could say, what's the, how much are they getting at 2 o'clock? How much are they getting with their dinner, right? So let's say breakfast, lunch, or dinner, or bedtime, what is it? It's breakfast, right? So it's breakfast time, it is 0800 right now. All right, all of this is in the problem, and it's 0800, it's 8 in the morning, right? And what's my blood sugar at 8 in the morning?
300.
It's 300. He had a busy night. He had some Snickers, and I'm not sure what happened, but he could be super sick, and that's why his sugar's been high. All right, 300 blood glucose, BG, blood glucose, and then what else we need? We can say he has a 12-year-old daughter. He's 76 kilos. He's probably not 76 kilos. Probably like 176 kilos. Usually diabetes associated with overweight. And that overweightness puts more and more need for insulin. All right, so he's 176 kilos. He has has 2 wives. He has three sisters. He has all the things, right? But we need to zero in on what's the sugar now, right? And now that's his ordered insulin, right? And that's really all I need, right? What's the time? Because the insulin might vary, right? So 300 blood glucose, and I'm going to say how many units of insulin will he get for breakfast at 8 a.m., right? So I can say ask the total units, or how much of 70-30 is he going to get? How much of the other ones is he going to get? All right? So again, it's just looking at the table, looking at the stuff, looking at the problem, and interpreting the information, right? So how much sliding scale insulin will he get? Or let's say, I didn't define it. He's getting sliding scale high dose, let's say aspart. So how much aspart is he getting? Sugar's 300, so he's getting 12, right? So we got 12 units of aspart, 12, sort of. Okay, he's getting 12 aspart, and then how much 70-30 is he getting? How much preprandial is he getting? I should zoom in here, sorry. Preprandial is he getting? And then how much detamere is he getting? What is preprandial? What is prandial? Because preprandial is before that. Prandial is your meal, all right? All right, I'm trying to think of an English word. It's just Latin or Greek for meal. I don't know. All right, so prandial is your meal. All right, so before meals, I get. Is this patient going to get some insulin? How much? 12 regular. This would probably say regular instead of preprandial, right? So let's just erase that and say regular insulin. How much regular insulin are they getting? 12, right? And then how much 70-30 are they getting? 0. None, because it's not 10 o'clock, it's 8 o'clock, right? And then detamere, how much detamere is he getting? 22. Okay? So this problem involves interpreting the data in front of me, right? And we can add a few other distractors there, but that has all the things, right? So temps, So it's either Celsius to Fahrenheit or Fahrenheit to Celsius, right? A good example of question is, here's a thermometer, what is it, right? Or here's the temperature. You have to have the temperature. We're not going to make you calculate temperatures and exothermic reactions, and then you're going to find out, solve for this if it's boiling water or boiling alcohol. No, right? You have to get a temperature. There has to be some kind of thing you have to interpret a temperature from, okay? So some things, I think on the practice math, maybe, I don't know if it was where that was, but where you have to read a MAR, right? And it says give acetaminophen if your temperature is greater than this, and then you pull up the thermometer and it's the wrong units. Shoot, right? So you have to figure out, am I giving Tylenol or not, right? So, but that's pretty as complicated as you can get it. I can't think of any other ways to make it as complicated. You have to have the actual value, right? And you have to solve it, and you might have to have a second step where are you given a medication or not, right? Are they febrile or not? Okay. So the conversions. So which one's bigger, Fahrenheit or Celsius? Fahrenheit's bigger, right? So if you're going from Celsius, a small number, to a big number, you're going to use the bigger conversion, right? And what does that mean? There's what, 9/5 and 5/9? So those are the two, right? Is that correct? Right? So one, you're using 9/5 as a conversion factor. The other one, you're using 5/9, right? So which one uses 5/9? The one where you're getting smaller. You're going from Fahrenheit to Celsius, right? The one where you're going bigger, you're going 9/5, right? So where do we start? Which one's which? What's the formula? C minus 32, we're getting smaller. So what's our consensus on Celsius to Fahrenheit? We're getting bigger, right? Is it Celsius plus 32 times 9/5, or is it Celsius times 9/5 plus 32? Because those are two different answers. So it's 9/5, which is 1.8, right? 9/5 times Celsius, right? And then what? Plus 32? Is there parentheses here or no? So it's Celsius plus 32 times 9/5? We're all in consensus? It's this? Just this, right? 9/5 times Celsius, right? All right, we're in consensus, all right, we're in Celsius right now? Okay, so yeah, so 9/5 or 1.8 times Celsius, right? So just 1.8 C times plus 32, right? That's our equation, right? You're not going to get points off if you use 1.8, right? 1.8 is 9/5. That's an equivalency. That's math, right? So 1.8 C plus 32, not 1.8 times C plus 32 first, right? All right, so Fahrenheit to Celsius, what is that? So we're getting smaller, right? So what is it? So Fahrenheit minus 32? Times 5/9, right? What is 5/9 as a decimal? 5.5. That doesn't roll off the tongue as nicely, but all right. So 5/9. So these are all small numbers. 5/9 is smaller than 9/5, right? And we are subtracting, not adding, right? So that's it, right? Those are your formulas, right? Formulas are just memorization, and if you can figure out some mnemonics like the smaller, bigger, that might help you get the right one. Okay, all good?